My name is Pedram Naveed, and don't forget to complete your surveys. And I'll be talking to you about how the age of AI is changing data engineering for good. So I'm the head of marketing and DevRel and data actually at Dagster Labs. Dagster, if you don't know about us, we're a data orchestration company. We help you manage and build a data platform. So I'm just going to assume that if you're a data engineer, you probably feel like this little guy right here. In fact, it's probably why you're here. Pressure's at an all-time high. And I think we've all seen board-level AI mandates say that we need to get AI pilled as much as possible. There's billions of dollars at play, and there's not a lot of appetite left for slow-moving data teams. And even if the promise of AI is mostly hype, even if it's like 90% hype, that 10% is still a risk. And I think a lot of people are feeling like we can't just ignore it, right? And so if AI or some version of it is coming, I think we all have no option but to figure out what we're going to do, especially as it relates to data platforms. So why does this matter? If you ask people who have a lot of vested interest in telling you why this matters, they'll tell you things like 75% of enterprises are experimenting with Gen AI. And to show of hands, are you guys experimenting with Gen AI? Are you asking ChatGPT how to build a pizza? Yes, probably. And if you ask Gartner, who also is very interested in this problem, they'll say you can get 10 times more productive by next year just by adopting tooling. Now 10 times, that seems like a stretch to me. But if you can get maybe like 20% better, that's still pretty good, I would say. And if you ask Microsoft, who's definitely invested in this, they'll tell you you can get 10x returns on your investment in AI, which seems lofty, but even if you get a meager 3.7 return on investment, I think that's still pretty good. And so change is coming. And whether or not you believe these survey metrics, what matters is your CEO and your board does believe them, and they've seen them. And so they're going to demand that we do something about AI. Now, some of you look old like me, and I think you all remember the Hadoop era. So maybe we can talk a little bit about a paradigm shift that happened, not too long ago. Do you guys remember this stuff? Ring a bell? Everything was elephant-shaped for some reason. We had a lot of Hive and Hadoop and Cassandra. NoSQL was a huge thing. If you're old enough like me, you probably remember all of this. And you also remember that it was actually very difficult to do anything with data. Most companies could not really have a data platform because getting this stuff set up required a lot of expertise. Sometimes it required commodity hardware. It was kind of really terrible, actually, and not many people look fondly on these days. Remember when MicroStrategy was a BI company and not a Bitcoin house? Those were the days. That's all changed with the advent of cloud. Redshift came, Snowflake came, Databricks came and said, stop messing around with setting up Hadoop clusters and let us manage all of that for you. And some people were very upset, but I think a lot of us were very happy to let go of this burden. And the thing that happened is a lot of us were now able to have data platforms, whereas previously we couldn't, right? Unless you were a very advanced company or a very fast-moving startup, you probably didn't have a data stack like this. But now anybody can spin up a cluster very easily. All the infrastructure is managed for you, and if something's going slow, you take the dial that says spend more money, you turn it up, your things go fast. And that's great. We love that. Do you remember big data? Remember when we all said big data, big data, big data? And we were all worried about how much data we could process, and we wrote blog posts about the petabytes of data we eventually processed overnight. That's largely a solved problem too. We don't really care about big data. I don't think anyone here talks about big data. We just throw money or compute at the problem and it gets solved. And then tools actually just get better and better over time as well, and so we can process more and more data locally on our laptop that we couldn't do before. I ran like a 100 million row ingest through DuckDB. I aggregated, I joined it, and my laptop, which has very little RAM, was able to process it. In the old days, you'd need a whole cluster just to manage that kind of stuff. So big data kind of changed the game a little bit, and it just went away. And once we solved big data, the real problem we started to think about is actually complexity. What happens is, now that it's easy to get set up with the data platform, everybody wants in. You're looking at this, and I think there's probably two reactions. One is, this is easy. This looks like every other company I've been at. or you're about to get nauseous and you think, oh my God, what is happening? This is probably a simplified view of most companies these days. Probably the smallest companies have like a data platform this complex, and it only gets worse from here. What happened is it became easy to access and move data around, and so everybody wanted in. Wade from sales, Joel from customer success, Ed from marketing, those marketers, man. Lydia, they all wanted to get into the data platform. And what ended up happening is we just created a bunch of complexity. We traded off democratization. People got to be able to access more data, but we traded it off with governance and complexity problems. And then this happens, right? Everybody and their uncle asks you, why isn't this working? Why is that working? Why is my pipeline broken? Is my SQL correct? And data teams are left with just the burden of reactive work, countless requests, ad hoc questions, and fatigue. Dagster came and we tried to solve this problem. This was a few years ago. Dagster, the way I pitch it is like a unified control plane for your data platform. Our mission is really to help you solve that complexity issue. We flipped the traditional orchestration model on its head and we said, don't tell me about all the tasks that you're trying to work on. Tell me about the things you actually care about, the data, the models, the notebooks, the tables. And when you do that, you kind of actually get a lot of benefits out of it. You get to see data lineage for once. You get to minimize compute. And you get to simplify your debugging and observability. You get full end-to-end lineage. You get a modular, unified platform. And what I mean by that is today there's a lot of platforms that are very vertically integrated. They say, you know, we work really great as long as you're with us. dbt Cloud, for example, works great if you're in dbt, but if you want to look at your source data or where the data goes, you're out of luck. Databricks has a pretty great workflow orchestration called Workflows, but it works really well with Databricks. And if you're on multiple clouds or multiple platforms, it might not work great. At Dagster, we kind of believe you need a modular platform that's unified across all your tooling. And once you do that, you get a lot of benefits. You get to maintain things more easily. You get to work across teams a lot better. And this last thing is really around developer productivity. Dagster was built by Nick Schrock. He's the founder of Dagster, and he helped create GraphQL. He created Dagster because he talked to people like you, and he said, what's the biggest problem you're having? And this was like 5, 6 years ago. And they all said data orchestration sucks. We use it and we hate it. And he went and built Dagster from the ground up to have a really good developer experience. Don't believe me, just go try it. It's open source, you'll find out. It'll make your day better. It's a lot of words. Here's what Dagster looks like. There's really 2 parts to it. There's your data lineage. This is across your entire data platform. That's like a small sample of our actual data platform. You can see your data assets, how they're connected, the partitions, data quality checks. Really just anything about your platform is now visible. You can click into any of these. You can see the logs. You can see metadata. You can execute them. You can select a subset of them and say, just run these things. You can do anything you would want in a data platform. That's fine. On the right, you see the data health dashboard. If you've ever wondered, what is the state of my data platform? Today, you might have to look into like 8 different tools. You go to your Fivetran, you go into your SAP, you go into different tools, and you kind of try to piece together what went wrong. In Dagster, you can say, show me the state of my dashboards, break it down by team, break it down by division, by department, and you can click in and see what's going on. So Dagster was like built to solve that complexity problem. We've been used across all kinds of industries, pharma, biotech, healthcare, finance, fintech. I won't go through this all, but what's important is like we started talking to these companies about the problem we solved, and then they started talking to us about a new problem they're having, and there's 2 things really. One is they said, we love Dagster, we adopt it, we build it, but it's really hard to onboard our stakeholders. Not everybody wants to learn how to use Dagster. The central data engineering team's really happy with it, but getting a data scientist or an analyst onto the platform is a little bit more difficult. And then they also said, like, AI is coming, we really need a strategy and a story around this. And we solved this kind of in a funny way. First, we stopped thinking about going faster. We started thinking about building smarter. When you have LLMs and AI, I think there's a couple things that are changing. First, I think LLMs are going to help you build things more quickly. You can auto-generate ETL. ETL, nobody likes ETL. And if you can give really boring, crappy jobs to LLMs, I think that's a great thing to do. It can also help us optimize SQL, infer schemas. It can also do some predictive stuff, some automation in terms of healing, finding failures, scaling on demand. But I think the most important thing is now everybody can build a pipeline. And this sounds like something that happened a long time ago. And I know what you're thinking. Oh God, everyone can build a pipeline. That sounds horrible. My stakeholders, they can barely write code, and now you're going to give them access to my data platform. That sounds like a nightmare. And it could be. There's a risk that quality and governance will suffer yet again. A long time ago, do you remember 2016 when data scientists were sexy? Sexiest job of the 21st century? Guy, Jeff Magnuson, he was a VP of data platforms at a company called Stitch Fix. He said we should not write ETL anymore as data engineers. We should be building frameworks. If you're a data engineer and you stop writing ETL, can you put your hand up? Yeah, I didn't think so. 9 years. We've been talking about this for 9 years. I hear it all the time. Data engineers are going to work on frameworks, and they're going to work on things that matter, and we're not going to do pipelines anymore. And it doesn't happen. What happens is you do some invocation of this. Is my pointer working? No, it's fine. Some invocation of this thing on the right. You start by building a YAML framework because your data analysts, they're not going to write Python. And then you build this nice framework for them, and then you realize, oh, now this is like getting repetitive. I just got to dynamically generate my YAML, and you create a coding program on top of that. And then it gets too complicated, and you're like, okay, well, what if I just like took that coding language that I put on top of my YAML and just put another piece of YAML on top of it? And you do that forever until you die. I think that's sort of been the story of data engineering. A long, long time ago, I wrote, data engineering is going to change, and data platform engineering is going to be the role. How this is going to be done, I wasn't really sure, but I kind of had a feeling we're going to solve it. We're going to stop building pipelines, and we're going to build frameworks. Sounds familiar. We've all been talking about this. The thing that's true, I think, and we can probably all agree on this, is that like, if you don't scale a data platform, you're going to have to scale the number of data engineers to support them. You're going to hire more data analysts, and they're going to want more things. And if you can't scale your framework, you're going to have to hire more data engineers, and that's not really a great problem. So we built something to help solve this problem. We didn't realize we were building it for LLMs. We built it for simple humans, like your stakeholders, people who, how do I put it? They could learn to code, but they don't, or they could read the docs, but they won't. It turns out if you build for people like that, you're also really building for LLMs at the same time. What we found is we tried to get AI to build pipelines in Dagster normally, and it just wasn't working. The results were really bad. You try to get AI to do anything in Dagster, and it uses an old API, deprecated code, poorly written Python, just a lot of errors and bugs. And it turns out Dagster is just like a flexible framework, and LLMs are not smart enough for that. And it turns out your stakeholders are often not smart enough for that either. And so we built Dagster components, which is like, you know, a coloring book, and you tell them draw on the lines. Here's a framework for how to build a pipeline. The data engineer will build these components that can be used by downstream teams. And it provides a bit of structure and documentation to your pipelines. And what it ends up looking like is really this. On the left is Python code that's actually, in my eyes, not that hard to read and not that hard to write. But you know stakeholders and you know LLMs, they get confused very easily. On the right is what happens if you take that code on the left, you build it into a component, and then you provide it with basically a schema that says, here's how you bake a dbt project. And you can imagine this for any kind of pipeline work you want to do. Whoop. So all that to say, there's three things that kind of come out of this. I won't go through this too much. I think we're kind of low on time, but what we've seen as we talk to our customers is three things. They are able to reduce onboarding time for teams. Right now, with Dagster, if you use components, the central team builds basically a bunch of building blocks, and companies can go out and get that to their team and get more flexible ways to onboard. But another thing I found is like, even though I know how to code, I started to use components more myself because it's actually really easy and really fun. And it does this nice thing where it separates out the pipeline logic from the actual configuration, right? There is always boilerplate when you're orchestrating data, you're moving stuff around. And often what ends up happening is you mix that with the logic of like your business. With Dagster components, you split it out into a YAML file and into a Python file. The Python file becomes like the building blocks for how to build these things. And the YAML just becomes the declarative instructions on how to do that. And you can really easily add these things in without going in and updating a bunch of Python code, which is actually kind of fun. I'm not gonna lie. And then what ends up happening is more people contribute to the data platform, which is something we've all said we wanted to do. Well, you can now finally do it. The other nice thing is you get reliability. Because you have one single component that people are relying on, everyone's not implementing things their own way anymore. And so you get back that governance and quality control that you want while still enabling your stakeholders. You get more stability, pipeline failures go down, more governance, like all of this stuff is great. But I think what's really great is you can actually start leveraging LLMs for prototyping and building pipelines. Because you've defined this like very clear box, and you said, here's how a component looks, there's documentation, there's a schema, there's validation, there's tooling to work around all of this stuff. You throw an LLM at it, and it can actually finally, for once, figure out how to build a pipeline. And because it's dumb enough for LLMs, it's dumb enough for your stakeholders, which is my pitch to you all. So what's next? If you want to learn more about components, there's a URL there. It's kind of weird. Components is one word, Slack is one word, and Forrester TI report is one word. There's 3 QR codes. And that's it.